pp2014 paper, I recommend everyone to read the question. You can see the graph is very complicated. Okay, now what we have is a vessel, and then the height is 96 and the radius is 72 cm. So basically the largest one is the vessel, and then it cut the lowest part. So cut the lowest part, this part here, it represents in dot line. And then the height of the vessel is 60 cm. Now the water depth is 28 cm. So this one make the water very difficult to look at. How about we draw it by ourselves? Now we have a vessel, it's in frustum, and then it cut the lowest part. The waters here will be in the, you can see it's another fraction here, actually, it's another fraction here. And then this is the water, the amount of water. So first question asking you, find the area of wet. Wet means the surface contact with the water. So basically it's finding the curved surface area of this frustum here, okay, contacting the water. And then in terms of pi. Okay, so some revision for cone. How we calculate the curved surface area is using pi r l. L here is the slant height. So remember that you need to find the slant height. You don't have the slant height here, okay? Think about this. Now you want to find the middle frustum. So you only have the radius of the largest one. It means that first you need to find the radius of this one, of the middle one, middle frustum. And then in order to minus the smaller cone here, you need the radius of this one. How we find the radius? Always remember that when we have encountered those frustum question, it's always similar triangle. Because they are from one cone, right? Actually, they are from one triangle here, and then you're cutting them. So it's AAA, right? It's always AAA, so they are always similar. So now, you have 72 here. How can you use 72 to find the radius of the smaller frustum and the smaller cone? You can use the height to help, because you have the length ratio through the height. Okay, 36 by 96 minus 60 here, you can calculate this one. Okay, so we use the ratios to help us find out the radius. Okay, the ratios of the radius should be the smaller, the radius of the frustum over the largest cone. So R over 72 equals to the height of this two, the smaller cone plus the frustum over the largest cone. Always remember that what is similar is not the frustum, the similar shape, is the cone. So when you thinking about those questions, you need to think in the concept of cone. Okay, always thinking which cone minus which one can get the frustum. Okay, so we know that actually the middle cone here minus the smaller cone there, you can calculate the frustum. So after you calculate, you will find out the middle cone will have the radius 48. And then for the smaller cone, same methods here, find out the height ratio, and you will have the same ratio with the radius, and then the radius is 27. Okay, by this, finding out the radius, you already have this, you already have the height. Now you are finding the curved surface area, So you need the slant height. Okay, we can just find it in the one equation. This equation using Pythagorean theory, because right angles here. Okay, 48 square. Here 48 square, and then 64 square root, we will have the slant height times pi times r is the curved surface area of the middle cone, and then minus the smaller one is same the Pythagorean here, and then the pi, the radius, and you just calculate with your calculator, and we need to keep it in terms of pi, so you keep it in terms of pi. This is the final answer. Okay, this is method 1. For method 2, you can use ratio to help. So in this case, you don't need to find out the radius. Because for finding out radius, you need to find one by one, right? So you can directly use the ratio, but I think in concept, this one, method 2 here, is more complicated. So when you can directly find the radius, why don't you just directly find the radius? Okay, so method 2 here, we first find out the entire cone surface area. So the largest one, we find out the whole curved surface area here, And then we minus this part. And then we minus this part. And then we will have it. Okay, first, when we have the entire cone, we need to know the ratio of the area, surface area, right? So using the ratio of their length ratio, and then do some simplify. And then length ratio square is the area ratio. So square those numbers. So it will equal to the area ratio. So the area ratio is in this ratio. This is the largest cone, middle cone. Remember, it's a cone, it's not the frustum. And then this is the smaller cone, okay? So it should be this one to this one to the smaller one, okay? And then we can use the entire one times the middle cone times the ratio of middle cone. Then you can find the surface area of the middle cone, okay? Of the middle cone. And then we minus the lower part, the smaller cone, the surface area of the smaller cone. What we have will be the frustum, right? So we minus the entire one times the ratio of the smaller one, okay? So after you minus it, you will get the same answers here. Of course, here you can say it's a common factor. You can take it out. Okay, for B, the volume of water. So now B finding the volume. We need to use the 1/3 formula to find it. Remember to take a lot of the unit, okay? Always take a lot of the unit. If it changed, we it used to be in cm, right? Now it's in m's cube. So you need to change your unit at the end, okay? Okay, in this situation, actually we are finding the volume of the frustum. We are finding the amount of water. Actually, it's finding the volume of the frustum, okay? The middle frustum. So how to find is still the largest cone minus the smaller cone. You will have the middle part. Okay, in this case, if you are using method 1, if you are using this method 1, you already find all the radius, right? And the height, you have all the heights here. So you can directly do it without using the ratio. So I think this one will be easier for you. How to find the volume? 1/3 and then time the base area 48 square pi, the circle area, right? Time the height 64, and then minus the smaller one 1/3 27 pi 27 square pi times the height, and then you can calculate this results here. And remember that you need to change the unit. How you change cm to m cube? It's cube. So for 100 cm equals to 1 meter. So when it is square, this one will be square. So it's 10,000 cm square equals to 1 m square. When it turns to cube, then it will be 100 to the power 3 cm cube equals to 1 meter cube. Okay, so it's 100,000 here. Okay, after you divide it, it's 0.127 m cube. So it's larger than 0.1 m cube. So we agree with it. It did more than, right? Greater than, okay?